Hi guys, so in this lecture first we'll be discussing upon the conditions required for E1CB reaction to take place, and second we'll be discussing about the topic of substitution reaction versus elimination reaction. Okay, so let's get started first with the conditions for E1CB reactions are conditions for E1CB reaction. Okay, so first condition is obviously, so stable carbon ion and poor leaving group is the first condition. So stable carbon ion and poor leaving group. Okay, second condition is E1CB reactions are very rare reactions because organic compounds are weak acids. Okay, E1CB reactions, this is not basically a condition, it's just a fact. Okay, E1CB reactions are very rare reactions, as organic compounds are weak acids, and if they are weak acids they would be less willing to give away their acidic hydrogen, because of which we get a carbon ion in our intermediate, as organic compounds are weak acids. Okay, so now let's discuss the substitution versus elimination reaction topic. Okay, so we have new topic as substitution versus elimination reactions. Okay, so in this what we can discuss is, in substitution we have SN1 and SN2 reaction, and in elimination we have E1 and E2 reaction. Okay, so let's have something that we have halide, and we have to determine the type of reaction that will take place in that halide, and in which condition also as well. Okay, so we have first CH3Br. so obviously E1 and E2 are out of the question because we have no alpha hydrogen for this particular carbon atom, hence E1 and E2 are out of the question. So and also if we get a carbocation at this position, or which is only a single carbon atom, it would be highly unstable. So the type of reaction that it can undergo is 100% SN2 reaction, in which a nucleophile will come and will attack the Br and join this carbon atom from the back side. Okay, next halide we have something like this. This is a 1 degree halide. Okay, so in this also we'll say that obviously positive charge carbocation would be unstable in this compound as well. So majority would be SN2 only. Majority is SN2 only. And second is, if we have, means we can also have elimination reaction in this case, but except for the fact that we have a strong base and we heat it, we can also get E2 as well. Okay, but carbocation formation would be highly unstable on this 1 degree carbocation, so we won't be talking about SN1 and E1 in this case. Okay, what happens if we have something like this? Obviously this is a 2 degree carbon atom, so in this SN2 can happen if we have, even if we have a weak nucleophile. Okay, and second, E2 can also happen in presence of strong base. Okay, and the chances for SN1 and E1 are also there. Okay, good chances are there. Okay, so let's talk about weak base first. So we have weak bases like something like I minus, Cn minus, all the counterparts of good acids. Okay, SH minus, we have ACO minus, we have N3 minus, we have aqueous KOH. Okay, and let's talk about the strong base. Strong bases are whose counterparts are weak acids. Okay, so we have alcoholic KOH, NaNH2 minus, we have then ETO minus, this compound, or NH minus, also have Rn minus R. Okay, so actually this is a weak nucleophile, but it's a good acid. It's a weak nucleophile. Why it's a weak nucleophile? Because of obvious steric hindrance reasons. Okay, so now let's see for fourth compound what type of reactions can we have for this compound. This is a tertiary carbon atom. So obviously SN1 and E1 are the chances of going into SN1 and E1 are very high. Okay, for SN1 we need solute lysis plus room temperature, and for E1 we need solute lysis plus high temperature. Okay, it will itself convert it into positively charged carbocation in the intermediate. Okay, so SN2 chances are very less, because the nucleophile would be having a tough time competing with the three bulky sterically hindered groups attached to the carbocation or the carbon atom. But even E2 chances are also equally good if we have strong base, okay, plus little amount of heat or high temperature. So the thing here is, if you talk about what is the difference between a nucleophile and a base, the only difference is in nucleophile we have to see steric hindrance as well as basic character. Okay, but in base we just need to see basic character. Okay, hence SN2 I have not written for this type of compounds, but E1 will surely be written, because obviously we only see basic character in case of E2 reactions. Okay, so now let's discuss some of the examples here. So let's suppose I have RBr and I have Ag plus OH minus. So what will happen in this cases? We will be getting ROH and precipitation of AgBr. Okay, next let us deal with some of the examples here. So we would have some examples here that you have to identify major products along with the type of reaction. Identify major products along with type of reaction. Okay, we'll just see one example and then we'll take rest in coming video lecture. So we have here a reaction and the type. Okay, so you have to identify major products along with the type of reaction. Okay, let's see first example. We have something like this compound will be acting as, we have to see whether it acts as a base or a nucleophile, and then it gets converted into something like CH3, this compound. So obviously this is a type of SN2 reaction. Why? Because we don't have solute lysis in this case, plus it's a good nucleophile, and it actually substitutes Br atom as a Br negative. Okay. So with this we come to an end of this lecture. In the next lectures we'll be seeing some more examples on this topic. Till then, good luck and goodbye.